Let's talk about refraction as it relates to lenses. The two types of lenses I want you to know about are converging and diverging lenses. Converging lenses are thicker in the center than at the top and the bottom, while diverging lenses are thinner in the center than at the top or bottom. Converging lenses bring parallel light rays together, so all rays of light converge on a single point. The lens in your eye is a converging lens, as is a magnifying glass. Diverging lenses spread parallel rays apart, so all rays of light diverge as if from a single point. Some eyeglasses use diverging lenses. Images formed by lenses can be classified into two groups, real and virtual. By real, we mean that the image can be projected onto a screen. You could focus rays of light as they refract through the lens. Real images will be on the right side of a lens ray diagram. Virtual images can't be projected onto a screen. You can't focus rays of light that have refracted through the lens. Some of the rays of light may have reflected instead, but the refracted rays will not form an image on a screen. Virtual images will be on the left side of a lens ray diagram. Here are the basic parts of a ray diagram. First of all, you have a lens in the center and a principal axis running horizontally through the lens. On either side of the lens is a focal point, which is where rays of light will meet up. The focal point always tells you how to angle rays of light when they refract. More on that later. Since all lenses we'll be discussing are assumed to be part of spheres, the lenses have a center of curvature and a radius of curvature, where the radius is the distance from the lens to the center of curvature. The radius is double the focal length, and the focal length is the distance from the lens to the focal point. Lenses have focal points on both sides. The focal points are the points closest to the lens, and then the centers of curvature are the points farther from the lens. Ray diagrams are pretty simple as long as you pay attention and come prepared. Pause the video and gather the materials in the list if you don't have them already. Got what you need? Let's do this. This is a converging lens, since the center of the lens bulges outward. My object is the white arrow, which is between the focal point and the center of curvature. All ray diagrams are two rays of light, one horizontal, one angled. Our first ray of light will go from the top of the arrow horizontally to the lens. It will then refract at an angle and go through the focal point on the far side of the lens. In short, parallel in through the focal point out. The second ray of light goes in at an angle through the focal point, then will refract horizontally. In short, through the focal point in, parallel out. The intersection of our refracted rays is the tip of our image, which we draw as an arrow that starts on the principal axis. Our new image is real. It's inverted, or flipped over, larger than the object was, and farther from the lens than the object was. For converging lenses, your steps are as follows. Parallel in through the focal point out through the focal point in, parallel out. This is another converging lens. The difference between the previous diagram and this one is that the object is now closer to the lens than the focal point. That will make our diagram a little bit different. The first step is the same, parallel in through the focal point out. The second step is a little harder. We can't go down through the focal point and expect to hit the lens, so instead we go up from the focal point to the top of the object to the lens, through the focal point in. And then we draw our horizontal refracted ray, parallel out. Since these refracted rays don't intersect on the right, we're not going to have a real image. Instead, we'll have a virtual image. To show this, we use dashed lines and continue our refracted rays backward until they intersect. Draw your image. Notice that it's upright. All virtual images will be upright. Your image is also larger than the object was and farther from the lens than the object was. This is basically how a magnifying glass works. When your object is very close to the lens, you get a virtual, enlarged image. To recap, for a converging lens with the object closer than the focal point, follow these steps. Parallel in through the focal point out through the focal point in, parallel out, dash back to intersect. This last ray diagram is a diverging lens, where the center is the thinnest part of the lens. Diverging lens diagrams are a little tricky because everything ends up really small. Start off the same as before, parallel in. Now we run into trouble. Diverging lenses will not bring light down through the focal point. They spread light out. So this time, instead of going down through the second focal point, we angle up from the first focal point, through the focal point out. The second ray of light also gives us trouble. We've already used the first focal point, so we can't use it again. Instead, aim at the far focal point until you hit the lens, then draw your horizontal refracted ray, through the focal point in, parallel out. Since the refracted rays don't intersect, dash them back as virtual light rays until they do. Draw your tiny upright virtual image, which is closer to the lens than the object was. This picture shows the image you get from a diverging lens. It's a really clear image, just shrunk down. To recap your steps: parallel in through the focal point out through the focal point in, parallel out, dash back to intersect. And that's it for ray diagrams. Go practice.